Okay, so section 2.1 exercise. I'm looking at them here. I think I'll do exercise 70 here first. So here they're saying use the alternate form f of x equals 3 over x, and they're asking us to find the derivative at c equals 4 or x equals 4. Now, the alternate form, all they're doing is saying that you can set this up as an actual slope that way, and so I'm trying to, let's see, we need to find it here. Okay, so I think, well, I'm trying to find, oh, there we go, top of page 101. So page 101, top. There we go. Sorry, I didn't have that right off. But what they say is, what we can do is we can look at, and you could use an x or whatever you want, but f prime of c is equal to the limit as x goes to c of f of x minus f of c over x minus c. But you see that f of x is some x, so if I'm drawing this, 3 over x looks something like this, and here's say 4, and so this would be at 3/4 in height. But what we're doing is x could either be above or below. I'm going to draw x below the 4 here. But you see, here's the point x, f of x, and here's the point 4, f of 4. And so you see, we're just getting the slope of that, what we call a secant line, and so that's a perfectly nice way to think of it. And it's really no different than using the h. It just makes for some different looking algebra. But so we can set it up this way. It's doing the same thing. We're coming down here and making these tangent line, these secant lines more and more similar to the tangent line. And so let's do this. The limit as x goes to 0, and f of x is 3 over x minus f at 4, or c is 4, so over 3 over 4 over x minus 4. Now the game here, see, this x minus 4 is really our h at this point. And so we need to get x minus 4 to factor out of the top. Okay, so it's still the same basic game. Whatever's down here, I'm trying to factor that out of the top. So, common denominator. So this is the limit as x goes to 0. Multiply this first one, 4 over 4, so I'll get 12. And then minus 3x, and that's all over 4x. And then times x minus 4, because I invert and multiply. And so notice that, this 12 minus 3x, well, if I factor out a 3, I'm left with 4 minus x. So actually I'm going to factor out a negative 3. So this is the limit as x goes to 0 of negative 3 times, and if I do that, negative 3 makes that a negative 4, and then this a plus x, all over 4x times x minus 4. But you see, that one and that one are the same thing. so that's like pulling our h out, so this would be the limit as x goes to 0. X goes to, why did I? People need to yell over the internet in a video or something. X goes to C 4. So sorry I screwed that up, but at least I caught it finally. So this is all 4s. Because heck, you know, I mean, if with 0, I wouldn't have had any problem. Well, no, I couldn't have put it into the top part there, could I? But once I got down here, things were looking much better as far as putting 0 in. Well, no, I still had the X, so yeah. But yeah, we want this to go to 4. We want it to go to C, which is, you know, we want it to go to C, and then that's 4, and so forth. See, I'm usually used to writing h goes to 0, and so that's where I screwed up. Okay, so this is our x minus 4 over x minus 4, and the limit as x goes to 4 of what's left, negative 3 or 4x. And so again, yes, that's 1. I can do direct substitution here, and I get negative 3 over 16. Okay, so that is our derivative at, well, I have C there, but it, yeah, f prime of 4. That would have probably helped me. Maybe not. But f prime of 4, and then we get all that. So that was kind of ugly the way I did that, but hey, we got there. Won't be the last time I screw something up. So minus 3 over 16, and so now I forgot what the directions were on number 70 here. We were supposed to use the alternate form to get the derivative if it exists. Okay, so got that. And so that is number 30. I'll do one more of those to maybe try to do it right this time.